We're at the point to refine. It's the number 6 step, and what we're going to do during this period is we're going to challenge what we've come up with. What we feel is our best solution. Is it actually going to work as we have it figured in our minds? And we have the drawings and everything. So basically we just want to challenge. We want to challenge different things like our material selection, how everything's going to hold up. And at this point we want to start considering safety aspects and also durability aspects. We're going to take the safety aspect first. This is grounding. And by effectively grounding, we're going to make sure, we're going to ensure the fact that Ted is going to be safe when he lays on that and there's an electrical storm in the neighborhood. So we want to ground it probably diagonally on the heat exchanger, the portion that is actually going to be the interface between him and the water, and we want to get that down into the ground with a ground rod, I'm going to say 30, 36 inches deep. And we know that if any component gets hit by lightning, it's going to travel to that path and not through Ted. We want to make sure that not only Ted is safe, but if you're out there with him, that you're safe also. Along that line, there's several aspects that we have to consider for durability. Anytime that you have water moving, you have electrolysis building up, which is going to be a corrosive situation. So the tanks or the tubes or anything that we put into the ground, it is going to be tremendously corrosive. So there's certain things that we're going to have to do to ensure the fact that we're not going to lose everything we have. Ground rods, once again, grounding straps. There are components called sacrificial alloys, and that's quite simply a zinc pod. You can order them. They've got threaded ends. We just weld a nut onto something, screw them on, and it is going to take and focus the corrosion. They use these on ships and different anything that has water and electrolysis that sets up. So we want ground. We want possibly to encapsulate any subsurface component in epoxy. This epoxy should have a high content of zinc, because we know that zinc is going to function as a sacrificial alloy, and the stray current, the electrolysis, is going to go to that because it's going to be the point of least resistance. So those are the key components. We want to refine our plan, and then we want to hit the ground running.